In Lesson 75, you'll be learning to figure out the area of some more complicated shapes and also figuring out the area of a trapezoid. Let's just do this lesson by working on some practice problems. Calculate the area of that shape there. Why don't you pause the CD and see if you can figure it out on your own first. What you have to do is break it up into shapes that you're familiar with. So what you can do on this problem is break it down into a triangle. See if you put a dashed line right through there. Do you see the triangle now? You can break it into that triangle and the big rectangle. So that triangle, you need some lengths for its sides. You have that right vertical side of 15 and that left one of 10, so that means this side must be 5 centimeters long. And then across the top you have that long side of 15. The bottom of the rectangle is 9. 15 minus 9 must mean that this is 6 centimeters. So now you have a triangle plus a rectangle that you can add together. The triangle would be 6 times 5 divided by 2. We can assume that this corner right here is square or a right angle. So the base times the height perpendicular to it divided by 2. 6 times 5 divided by 2 plus the area for the rectangle of 9 times 15. We can reduce 6 over 2 to 3 over 1, and we end up with 3 times 5 over 1, or just 15, plus 9 times 15 would be 135, and that gives us 150. Our units are centimeters, we can't forget those, centimeters squared, or 150 square centimeters. Let's do another one, figure out the area of this shape. Just don't make these any more complicated than they need to be. You're always just going to break them up into shapes that you're familiar with. And for right now, that'll mainly just be rectangles and triangles. So what I would do if I were you is put a dashed line right through there, and you can recognize that you have a square and a triangle. This triangle, this side would be 5 and this side would be 9. We can assume that's a right angle or square corner right there. And we'll be adding together the area of a rectangle plus the area of a triangle. The rectangle is 9 times 10. The triangle is 9 times 5 divided by 2. So we'll end up with 90 plus 9 times 5, or 45 over 2. Let's just use decimal form on that. 22 and a half, or 22.5. And so that will equal 112.5. I didn't specify any units on this. Let's do inches for this one. 112.5 inches squared. On these more complicated shapes, make them into easy shapes by breaking them up into shapes you're familiar with, then calculating the area of each of those individual shapes and adding them together. Let's do one more. Look at this problem. There's an easier way and a more complicated way to do this problem. The more complicated way would be to break this up into 2 triangles and a rectangle. The easier way is to recognize by making a diagonal that you have 2 triangles in this problem, both of which have that perpendicular height of 8 to their bases. The triangle on the bottom has a base of 8 and a perpendicular height of 8. The triangle on top has a base of 8 and then this perpendicular, base of 18 and this perpendicular height of 8. We'll use centimeters for our units on this problem. This is called a trapezoid, where you have 2 parallel sides. That top and bottom side are parallel. A quadrilateral, or a 4-sided polygon with 1 pair of parallel sides, is called a trapezoid. If it has two pairs of parallel sides, it's a parallelogram. So what we need to do here is, let's do the bottom triangle, 8 times 8 over 2, plus the top triangle, which has a base of 18 times its perpendicular height of 8 over 2. We can reduce both of these fractions. 4 times 8 is 32, plus 4 times 18 would be 72, for a total of 104. We use centimeters for our units on this one. Square centimeters is the area. Recognize when you have a trapezoid, and that will help you simplify your problem solving. Whenever you see a problem like that, they will give you the height perpendicular to the bases, and just recognize that you have a trapezoid there, and that will speed up your work. Make sure you use the appropriate units too. Remember, the units are half of your answer. If you get the units wrong, but the answer right, the numerical part right, then you get half credit. If you get the numerical part wrong, but the units correct, you still get half credit. If you need some more practice on these problems, there are some supplemental problems in the back of the book. And then, as always, you can do the practice problems in the textbook as well, which are similar in concept but different results than the ones that I do. Okay, well, that's all for lesson 75.